Well, here we go. As promised, I said it was the inevitable. So as you can hear, I just have a slight cold. I'm okay. Just a couple quick reminders. Number one, again, with this video, you can learn from a video. Please take notes with me. That means like pick up your pencil and do the problems with me. The other thing that's going to be really important is that you remember that you can pause the video to try something. You can rewind the video if you don't understand. All of those are options. My hope is that they'll let me come back on Tuesday because that will be the 5 days. However, there's no promising. Your test is still next Friday. So again, I can't say it enough. I cannot reteach. I can tweak, but I cannot reteach. So this is on you today to take your time. I know you can do this. All right. So here we go. Here is probably the number one missed question on our formative. Given triangle JOV is similar to triangle ADV, I gave you some distances and I asked you to determine the ratio of the perimeters in terms of X. That basically is asking you for the scale factor. A ratio is a fraction. So your answer is going to be a fraction in terms of X. All right, so here we go. First things first, I gave you the similarity. I gave you the distances. So I would create my equal ratios. Some of you on your formative are not using the equal sign. You're using the similar sign. That's locomotion. You need to be using equality. These fractions are equal. Figures are similar. All right, so I'm going to go ahead, set up my ratios like we always do. Again, remember, Miss Parisi is not that clean on the iPad, so please no judging. I'm going to go ahead and replace my quantities with what I know. I know distance dV, and I know distance JO. All right. Just like on your formative, you cannot solve this. There is no two fractions where you know a numerator and denominator. You cannot put X into OV. Only Miss Parisi can. You could put a Y there, but I don't know how that's going to help you. So again, a ratio means that I want a simplified fraction. So therefore, all I do is I take this fraction, and this is going to give me my scale factor in terms of X. Now, I need to simplify this. To simplify means those are both quadratics. I need to factor them. Factoring, again, you can use the area model. You basically need to turn this into two binomials. You can't just like cross off the 4 and the 16. Again, no, that is a standard form. You need to factor these. So here we go. I'm going to go ahead and factor my numerator. I like to make my area model. I got a 4x squared here, a negative 15 here, a 7x there. I got to think of numbers that work. I'm going to take my time. I'm going to do, let's try 4x and x. That would make x squared. Numbers that multiply to 15 are 5 and 3. If I put the 3 here and the 5 here, that would give me 12 in this square, 5x in this square, which again, I can get to make 7 if this is negative and this is positive, and everything else holds true. This would be a positive 12x. That gives me a negative 15. So everything has been factored. So I end up with x plus 3 and 4x minus 5. Okay. Again, now I'm going to factor my denominator. I factor a denominator. Again, it didn't look like we gave you enough room, so I'll go down here. Again, I have 16x squared there. I have negative 25 there. And I need that to make 0. Well, the only way that terms can make 0 is if they're opposites. In other words, think about it. 8, negative 8 makes 0. 9, negative 9 makes 0. So, and again, I'm kind of looking up here, the numerator to kind of help me. And I notice that, wow, if I put that and I make that look exactly like my numerator, if I make that one a plus 5, that gets me a negative 20x. That gives me a positive 20x. That makes 0. Everything works out. So now I end up here. All right. So again, I'm coming up with my scale factor in terms of x. A scale factor is a ratio. There's my ratio. I simplified it. Now I can go even one more step. I can simplify it even more. I can eliminate those because those are identical. And now I'm getting the answer of x plus 3 over 4x plus 5. Now, the only last thing I need to do is I need to algebraically, that's where I'm sitting right now, I need to think of restrictions. In other words, if you pull out your calculator, if you divide 0 by a number, you get 0. But if you put a 0 in the denominator, you get an error message. You're not able to take something. If you have 9 pieces of candy and I ask you to divide it up into 0 piles, you can't. You have 9 pieces of candy. So my point is only your denominator cannot be 0. Your numerator can. So again, my restriction should only come from my denominator. The way I come up with restrictions, ladies and gentlemen, is all I do is I take my denominator and I figure out the x value that would make them 0. Oh, people are texting me to get my subplans. So here we go. I would, let's do that again. I know you're laughing. All right, here we go. So all I do is I set those equal to 0. 4x minus 5 equals 0. 4x equals 5, x equals 5/4. So that is a bad x. That x would make my denominator 0. I do the same thing with the other one. Negative 5/4. So oops, let's box the whole answer. So in order to be a proficiency in this skill, you need all of that to be your answer. This is my scale factor in terms of x. Oops, I lost my 5. And these are my restrictions, which again come from my denominator. The question I get often is, why do I have to use the one that I eliminated? And that's because if I did, in fact, substitute 5/4 into the original problem, it would still cause my denominator to give me 0. And again, we cannot have a denominator of a fraction be 0. Please feel free to pause the video, take a moment, ask a neighbor a question if you have any questions. But that is how we do a scale factor in terms of x. All right. All right, here we go. Today we're going to do application problems. Application problems are no different than normal. We're still going to have to create. The only thing we're going to have to do that's different is create the triangles because I didn't give them to you. Then we have to prove them similar. If you don't prove them similar, you are assuming. And if you assume in my class, you know what happens. Once we do that, once we prove them similar, then we can come up with an equation. We can then use our algebra to solve and then answer the final question. The strategy I use with word problems is I always do a 3-read. So here we go. Carlos is standing in front of the Green Monster, the left field at Fenway Park, home of the Boston Red Sox. If you've never been there, it's pretty awesome. There's a small mirror between Carlos and the Green Monster. The mirror is 2 feet 9 inches from Carlos and 18 feet and 16 inches from the Green Monster. Carlos looks into the mirror and sees the top of the Green Monster. If Carlos's eyes are 5 feet 6 inches from the ground, how tall is the Green Monster? All right, so my first read, I just kind of read it. My second read, I'm going to go back and figure out what I have in this problem. All right, I got Carlos. Here's my Carlos. I got this Green Monster, which is this big old wall. And I have this mirror, which is somewhere in between us, not necessarily in the middle. Sad news, this is what we were supposed to actually physically do in class the other day, which makes me sad that we didn't get to do it. All right, here we go. I don't see triangles yet. Those are just my things. So my second read, I just kind of try and get the people. And then my third read for me is figuring out what quantities they gave me, which isn't hard in math because they're numbers, but I got to zoom out. So I see 2 feet 9 inches, but again, I got to zoom out. That is, the mirror is 2 feet 9 inches from Carlos. So if I label that distance, that's from here to here. Now, I can't do 2 feet 9 inches. I got to be in the same units, right? So again, I need to understand that for every 12 inches equals 1 foot, right? So therefore, I know that Carlos is 2 feet, which would be 2 12s, right? 12 inches plus 9 more inches would give me the total that he is. So if I do that, that's 24 plus 9. Uh-oh, I must have COVID brain. Well, 24 plus 10 is 34, so that has to be 33 inches. You could also go the other way. It looks like the teacher who keyed this, she decided to turn everything into feet. That's another option. You could say that 9 is, where am I getting 9 from? Oh, yeah, there's 9 right there. 9 is 3/4 of an inch. You could think of it that way, too. And so, therefore, you could do that it is 2 3/4 or 2 and 0.75, however you want to do it. I like to stay in inches. I find that easier personally. All right, then I'm going to do it again. I'm going to zoom in. I know that the mirror is 18 feet 6 inches from the green monster. So that is from the mirror. I'm going to use a different color. So from the mirror to the green monster is 18 feet, which again, 18 times 12 plus that additional 6 will get me my answer in inches. So again, this is giving me an answer in inches. All right, let's Miss Parisi go grab her calculator because it seems like that would be a helpful tool to have. Ooh. All right, so I'm at 18 times 12 plus 6 is 222. Again, you could also go the other way. You could say that you can go into feet, so it would be 18.5 feet, right? Because 6 inches is a half of a foot. I don't care how you do it. It is totally up to you, okay? If I keep reading, Carlos looks into the mirror and sees the top of the green monster. This is kind of really where we were hoping that we would do that activity yesterday. There is a video. But basically what happens is that he looks down into the mirror. And when you look down into the mirror, you can actually see the top of the green monster. So there you go. There's your, oh my gosh, you see what I made? I know it's crazy. Miss Parisi made triangles. So there's a triangle there, and there's a triangle there, which is going to be helpful. All right, if I keep going, it says that if Carlos's eyes are 5 feet 6 inches, so that means, again, from here to here is a distance of, too thick, 5 feet 6 inches. I know, again, 5 feet, 5 times 12, plus an additional 6. So 5 times 12 plus additional 6 is 66 inches. Again, you could go the other way. You could say it's 5.5. That's fine too, because it would be 5. That would be in feet. This is in inches. And they want to know how tall is the green monster. So that's what I'm trying to find there. That's X. All right, here we go. The first thing I need to do, no, it is not to just set up ratios. The first thing you need to do is you need to label your diagram and find the similar triangles. So here we go. I know that when I build a building, it is perpendicular, and I'm going to go with Carlos's standing perpendicular to the ground. There is one pair of congruent angles. Also, I can say that these two angles are congruent. Those two angles are not vertical angles. They are not formed by intersecting lines. Those are actually called angles of reflection. That just means that, again, if you think about it logically, if you kind of use symmetry and flip that triangle along this kind of line right here of symmetry, those two angles logically have to be the same. So now I have proved my triangle is similar by angle. If you don't have those angle markings, I do not have a proficiency of a 3 for you. All right, here we go. After that, I think it's pretty easy, in my opinion, to see which sides correspond. I'm not even so sure you need to name the triangles and all that stuff. So again, I'm going to make ratios. Why am I making ratios? Because I'm dealing with side lengths. All right, why is this gray of all colors? Maybe we'll figure that out later. All right, so I would do 66 corresponds with X. and 33 corresponds with 222. Yes, those are the corresponding sides. If you really wanted to, you could name your triangles with letters and then set up ratios. But again, I feel like you can very clearly see which sides correspond. I use my cross multiplication. Now I'm in algebra world, so this is my setup equation. Now I'm going to go to algebra. My algebra would be that 33x equals, oh, that's why, because I'm using the wrong pen. Spastic. And 222 times 66 is that, divide by 33, and I'm getting x to be 444 inches. Again, if you want to know what that is in feet, because maybe that's weird for you, again, we go back to our key. We know that for every 12 inches, it's 1 foot. So I can just take 444, divide by 12. And if I wanted my answer, I could also say x is equal 444 inches or 37 feet. Do I care? No, I just care that you tell me which one you gave me. So make sure you put your units down and use your final answer. That would be your conclusion. So in order to get full credit, I need a diagram. I need your angles labeled so I can see how you knew they were similar. I need your setup equation, your algebra, and then your final answer. All right, again, if you need to pause the video or rewind, please do so. Let's try another one. Again, kind of read. I read it first just to kind of figure out what the heck they're talking about. Sam is standing at a light post that is 12 feet tall and is casting a shadow on the ground. He walks away from the lamppost and along its shadow at a rate of 3 feet per second for 1.5 seconds until the shadow meets the end of the lamppost shadow. If Sam's shadow is 3 feet long, how tall is Sam? Okay, so again, my first point of just reading is just to read and to figure out what I have in this problem. So for me, I notice that I have Sam. He's standing at a lamppost. We're talking about shadows on the ground. He walks away from the lamppost, and then his shadow meets the lamppost shadow. So here we go. Here is my lamppost. We'll go like that. And here is Sam right now. Sam is right here. Sam is standing in a lamppost. He walks away from the lamppost. And then now he's here, right? Here's my Sam. He walks till the shadow of the lamppost meets his shadow. So again, if we think about this logically, here's the lamppost shadow, right? Shadows are on the ground. And here would be his shadow, because again, here's your sun, and the sun kind of creates rays like that. So if I look, I can see that I have triangles. Where are you seeing triangles, Parisi? Well, I have the big triangle formed by the lamppost shadow, and then there you go. And then I also have Sam. Here's his shadow, and then here's the sun's rays. So those are the two triangles I'm kind of looking at right now. All right, let's start labeling quantities. Again, zoom in, zoom out. It says that Sam is standing at a light post that is 12 feet tall. So Sam is not 12 feet tall. The lamppost is 12 feet tall. He is casting a shadow on the ground. He walks away from the lamppost. Oh my goodness, what's this? Craziness. He walks away at a rate of 3 feet per second for 1.5 seconds. So how do I figure out this part? Because it's telling me how far and what rate he walked from this point to this point, right? Because that's where he started and where he ended. Well, oh my goodness, she's crazy town. We're going to bring back our basic formula. Distance equals rate times time. Because now I can figure out what that distance is, knowing that my rate is 3 and knowing that my time is 1.5. So that will actually tell me how far he walked. So if I do 3 times 1.5, I get 4.5. So that is my distance here. If Sam's shadow is 3 feet long, so Sam's shadow is from Sam to where it meets. This is 3 feet long. How tall is Sam? So my unknown quantity in this problem is the height of Sam. All right, let's pause there. There's my picture. The first thing I do is not solve. I first need to prove the triangle similar. So here we go. I know that Sam and the lamppost both make 90-degree angles. And if you're really with me, I have overlapping triangles and they share an angle. They share this angle right there. If you don't have those angle markings, then I cannot issue your proficiency score in Standard 1A. Now I'm going to go ahead. Again, I have some kids who really like, they put letters on it and name them. Some kids will pull them apart. I personally just kind of start comparing. I might just kind of redraw just so you can see what I'm doing for you guys. But again, now that I proved them similar, I can see what matches up. So here we go. Here's my big triangle. Here's my little guy. I know this is 3. I know this is X. But please, this is not 4.5, guys. That would be just the trapezoid. Remember, we got to use the triangle. So this is 7.5 and this is 12. So my ratio would be 12 over X because those correspond, and 7.5 over 3. I'm going to pause there. That is my equation. That is my setup because I'm comparing side is to side is side is to side. Again, those of you in your formative, this should be an equal sign. You do not make ratios similar. That's locomotion. Okay, the figures are similar. These are equal. Now I cross multiply. 7.5x equals 36. 36 divided by 7.5. And I'm getting x to be 4.8. I need units. 4.8 feet. What does that really mean? Well, if I'm 0.8 of an inch, you could figure that out, but you can leave your answer as 4.8 feet. We are fine with that. Otherwise, you can do, that would be 4 feet, and that's 8 out of 12, right? Because so that would be, math, enter. You could also say you are 4 feet and 2/3 of an inch. However, I'm fine if you leave it as 4.8. Okay, that would be your final answer. So again, summarize. First thing I do, I read. I kind of get my picture down. Once I get my picture and I label, I prove my triangle's similar. Number 1 missed question because you don't do that. Label your congruent angles. Notice how I'm proving them similar by angle. I know you're shocked. Once I get that, I set up my ratios, but please be careful. You want to use the triangle, not the trapezoid. Cross multiply and solve. All right, last but not least, another great example of similarity is if you are a pool player. Playing pool is actually using similar triangles and angles of reflection and all that good stuff. So here we go. Given K is at 2.6, T is at 2.2, S is at 11.2, and R is at 11.6, and those are the corners of your billboard. Your cue ball Q is at 3.5, and your target ball G is at 10.4. Given you want to bank the cue ball off of TS and then hit the target ball, what coordinate on TS should you aim at? All right, so you have to understand a little bit about pool to be able to do this. Again, I got some of the picture down for you, but let's go ahead and add a little bit more. I'm telling you that your cue ball is at 3.5. Your cue ball is like the white ball that you hit before you can hit your ball. So again, I kind of have to use a little bit like this is my x-axis, this is my y-axis. So if I go over 3, up 5, I'd probably be around here, right? Because if this is 2.2 and that's 2.6, That would be over one more. That would be 3, and then up 5, down 1 from 6. And then G is at 10, 4. So again, 10 is over here. 4 is a little bit lower. I'm going to put that right there. There we go. This is my G ball. All right. You want to, again, I read it first. Now I'm just kind of labeling everything they're telling me. There's my that. Given you want to bank the cue ball off of TS. So again, this is my cue ball right here. And I want to bank that off of TS. And then hit the target ball. All right, so I like to highlight. So basically my goal is I want to take this ball and I want to, boom, hit here. Boom, that there. That's like why there's like those little diamonds on your table when you play pool, because you're supposed to use the diamonds on the edge to know where to aim. I know, isn't that shocking? All right, here we go. First things first, now that I kind of got my picture drawn, I got to find my similar triangles. I don't even see triangles. Again, if you've caught on, if I just go straight down, I can draw a perpendicular distance. If I go straight down, I can label a perpendicular distance. So I don't know about you, but there's one triangle right there. And there's another triangle right there. Okay. I can kind of label what they want me to, what I know, what I have to find. They want to know what is this point. So I need to figure out in the end what this ordered pair is. Okay. I might kind of do things a little different in this problem diagram. I can prove them similar. They already have one congruent angle. There's their other one. So now I have my similar triangles. And now I'm going to figure out what I can find on the coordinate plane knowing all these ordered pairs. Okay, so here we go. You have to understand, ladies and gentlemen, if you're talking about a horizontal distance or a vertical distance, right? So here we go. I can actually figure out this vertical distance. If this is at 5 and it started at 2, that means that this vertical distance is 3, right? If this side is starting at 4 and then goes down to 2, this vertical distance is 2. I'm using the Y values, ladies and gentlemen, because I'm talking about a vertical distance. The other thing I can figure out is this horizontal distance. This horizontal distance would be from 3 to 10. Again, that's telling me how far apart those 2 points are. I can clearly see that whole distance is 7. Now, you just don't cut that in half, dude. Like, there's no reason why I have to hit it at the midpoint. That's not what we're saying. I got to figure out where this point is. It's not necessarily in the middle. There's no reason. There's no scale factor that's a half. All right? So I got to be able to figure out a number here and a number here. So we could play the let's pretend game. Let's pretend that this piece was 5. If this piece was 5, this piece would be 2. Why is it 2? Well, because 5 plus 2 is 7. Let's pretend if this is 6 and the whole thing is 7, what's that? 1. How did you get that? 7 minus 6 is 1. So we've done this enough times in this class that if I don't know something in math, I call it x, which means I can call this distance over here, oh my gosh, you ready? 7 minus x. Now I proved my triangle similar by angle, angle. I can clearly see my triangles. All my quantities are labeled. I can clearly see which sides correspond. Again, you can redraw the triangles or name the triangles if you want, but for me, I can see them. And so now I'm going to set up my equation. I know that 3 corresponds with 2, and I know that x corresponds with 7 minus x. So all I did was just set up my ratios, comparing my triangles. There's my setup equation. At that point, I cross multiply. I know, all you number racist people out there, you're having a panic attack because you got a decimal. It's fine. All right, there you go. I got 4.2. So therefore, I have to understand that this distance from here to here is 4.2, right? And then this distance over here would be 7 minus 4.2. 7 minus 4.2, which is 2.8. Okay, so how do I use that to figure out my ordered pair? Well, I know that my y value is the same for both, right? All of the points. I already know this is a 2. It has to be a 2. It's on that same y line. And then for here, I say, okay, I know that the x value for this dot right here is 3. So if I'm at 3 and I go 4.2 more, 3 plus 4.2 is 7.2. I could also do it the other way. I could say, I know that this dot right here is 10. And if I go backwards, 2.8, 10 minus 2.8 is, oh my gosh, 7.2. So my answer is that is the point that I would have to hit to make the ball hit my target ball. All right. Next one. Last one. I would hope that you try this one on your own. Your blank is a 0, 3. If it were me, I would pause the video. I would read the problem. I would then go back, reread the problem, label your picture, all that good stuff. See if you can prove the similar triangles. See where, if you can figure out the side lengths, and then solve it. Let's see where you have trouble. Once you kind of get stuck or once you're complete, then I would unpause the video and listen to me and see if you got it right. You can always fast forward and see what the answer was. All right, go ahead and pause. I'm going to go ahead and do the problem so that when you come back, you can see if you are correct. All right, so here we go. It is given the corners of a billiard table are the following, and the cue ball C is at 4, 1, and the target ball A is at 0, 3. Find the coordinates of point R, where C will rebound off of segment LE to hit point A. All right, read it once to just figure out what the heck they're talking about. 2, they have some cue ball at 4, 1. 4, 1. Again, this is my x-axis. This is my y-axis. So if I go over 4, that would be about here. Go up 1, that would be about here. So that's Miss Parisi's cue ball. My target ball is at 0, 3. This is my y-axis. 0, 3 has to be higher than 4, 1. This is my A. This is my 0, 3. And they said, what else? Find the coordinates of point R. So that's what I'm trying to find, where C will rebound off of LE. So where is LE? There you are. So I need to, here we go. I need to take my cue ball. My goal is to shoot my cue ball, have it ricochet, and hit point A. So that's my goal. I want to know what point that is. All right, that's my goal. I do know, by the way, already that they're going to have the same x value, so I should know that. All right, here we go. Next thing I would do, probably get my triangles. So, oops, turn my iPad, but shouldn't. So again, if I go straight down, that makes a right angle. Straight down makes a right angle. And that angle are equal because those are angles of reflection. So I've proven my triangle similar. I labeled my diagram with that part. I'm also going to label some quantities. I can find horizontal and vertical distances. So here we go. I know x-wise that this starts at -2 and ends at 4. So I know this distance is 6. I know that this dot starts at -2 and ends at 0, so that is 2. So there's that distance. I know that from here to here would be from 3 to 1, right? That's how far apart they are, which is a distance of 2. So again, I just don't make it 1 and 1. God help me. They don't necessarily hit it in the midpoint. I got to figure out what those pieces are. So again, I'm going to call one of them X. I like to call the one that's like closer to 0 X. It doesn't matter. So I'm going to call that one X. And then this is 2 minus x, because isn't that how you would find it? 2 minus x. Whole thing minus the part. All right, I can prove my triangle similar. I can clearly see which sides match up. If you need to put letters on and do it, you're fine. But here we go. I know that 2 goes to 6, and that 2 minus x goes to x. Top is to bottom as top is to bottom. All right, there's my setup equation. Cross multiply. Uh, 12 divided by 8. I leave it as a decimal, by the way, just because it's easier on the coordinate plane for my brain to think about decimals. It's harder for my brain to think about fractions on the coordinate plane. Just FYI. All right, so now I know that this sucker is 1.5, and then that would be 0.5, right? So I need to know this ordered pair. So I know that point R. I know the x coordinate's -2 because I'm on that same vertical line. Excuse me. And then I know that this dot right here is located at 1, right? That's how high it is on the coordinate plane. So if I'm at 1 and I go up another 1.5, I end up at 2.5. And that is my answer for point R. So to summarize, I create a diagram, get my triangles. I prove my triangles similar. Once I prove my triangles similar, I set up an equation, and then I go back and answer and find the conclusion. Sorry. All right, so that's it. Homework. Homework is to do 7.2 IP, numbers 1 through 5. On Tuesday, I do plan on doing some review. However, you think I can reteach all this? That's impossible. I need you to understand. Tuesday we'll review. Wednesday's formative number 2. Your homework will be due Tuesday at 8 o'clock. If you are thinking you're going to need some help, please make sure you make arrangements with me. I'm happy to meet with you. Formative will be on Wednesday. Thursday will be review. And then Friday is your test. So over this weekend, please make sure that you get IP 7.2 number 1 through 5 done. I hope this was helpful, and I will see you all hopefully on Tuesday.